All right, this is actually one lesson that's actually got two different topics in it, okay? But I think we're just going to stick with the first one today, and then we'll hit the second one tomorrow. And so the worksheet that I'm going to give you, half the problems are on what we're going to teach today, and the second half of the problems are what I'm going to teach tomorrow. All right, so I think it's only like 8 problems that we figured that out in the other class that you had to do. So here's what we call it. We call it the law of sines. And tomorrow we'll do the law of cosines, all right? So it's the law of sines. This whole chapter has been a chapter about right triangles, but it seems kind of weird to put this in here because this law of sines, you actually use the law of sines when you don't have a right triangle. So why in the world would they put that in here when the chapter's all about right triangles? Why don't they put it on another chapter where you don't deal with right triangles? Well, it's a good question that you asked, so I'll answer it for you. Did you ask it or me? Anyway, so what it is the way that they came up with this law of sines is taken from right triangles. So you took like a non-right triangle and you broke it into a right triangle and you did a bunch of stuff, bunch of trig, and you came up with this thing. I'm not going to sit here and show you how they came up with this. I'm just going to show you what it is, right? If you're really interested in that and you're like, well, I really would like to know how they came up with this law of sines, well, you could always look that up. Khan Academy's got a good video. Khan does a good video on figuring out how to get the law of sines, all right, on proving it and coming up with the law of sines. And he does one, I believe, with the law of cosines as well. But I'm not going to do that. I think that's a little too much out of your comfort zone to do that. All right, so I'm just going to show you what the law of sines is. There's actually kind of two different versions of it. I'm just going to show you what it is right now. It might look a little bit weird to you, and then we'll show you how to use it. All right, so there's actually 2 different versions. Here's the version that I usually use. But it all depends on what you're trying to solve for. And we'll talk about what the little a and what the big A, what the difference is between them after we write it down. B over the sine of B. Now what's kind of weird on this is they actually put 3 things here. Even though they put 3, we're only going to use 2 of them. Alright, so there's the first one. You get that all written down, Josh? You got it all memorized. So there is, there's the first version of the law of sines. Now the second version of the law of sines is very much like this, except we just switch the a and the sine of a as far as top and bottom. All right, and you're like, well, why learn one and and learn the other one as well? There's reasons for it, but let me just write it down again, and you'll see. A lot of this stuff will make sense after we start doing some of these examples. So here's another way you could write it. It's not really a different law or anything. It's the same exact thing. It's just 2 different ways you could write it. So if I write sine of a over little a, what do you think I'm going to write this as? Good. Pretty easy, right? We just switch the top and the bottom. And then sine of c over little c. So you could write it either way. It doesn't make any difference. I just wanted to write them both up there for you. And I do have a preference, though, depending on what you're solving for. I do have a preference on which one of these that you're going to use. All right, and this has to do with triangles that are not right triangles. So let's draw a triangle that is not a right triangle. So let's draw, I don't know, let's draw this an obtuse triangle. We don't do obtuse triangles that often. Don't know why. There's nothing wrong with them. There we go. Now, what we really want to see is this. What's the difference between this little a and this capital A? Well, if we label this triangle, triangle ABC, what do the capital letters represent on this triangle? The angles, right? Okay, they represent the angles. So what do you think the lowercase, the little letters, are going to represent? The sides, right? Now, does it matter which one we put, A, B, or C? Can we put it anywhere? Not really. When we look at this formula right here, this A, what do you think? It has to be what to this capital A? Or side A has to be what to angle A? Give me a good word. We've used it before in some of the trig function stuff. Opposite, exactly right. Okay, so they're opposite each other. So if this is angle A right here, which one is side A? The one that's opposite. So this little one right here would be side A. Everybody see that? Let me scooch it up a little bit. Right there. See how it's opposite? It's across from it. Would you agree? What would I call this side right here? This side AC. Instead of calling it side AC, let's just give it one little lowercase letter. What would I call that? B. Why? Because it's opposite of angle B. And what about side AB, this side right here? What's a better way to call that? Little c, right. Okay, that's side C. So the lowercase letters are for the lengths of the sides. The uppercase letters, the capital letters, are for the angles. All right, so on each one of these, this means this side B right here is the B that's opposite, or the side that's opposite this angle B. Make sense? And this side C, obviously, is opposite angle C. So that's pretty important to understand about what we're going to do here. Remember I said there's three things here, but we're only going to actually use two of them? We're just going to pair them up. We're not going to use all three at the same time. We're only going to use two. We're either going to pair the first two together, the A and the B's and the C's, or the A and the C. All right, that's how we're going to pair them up. You with me on that? So we're not really going to use all three. It just depends. We've got three things because we got three angles and three sides. But when we use this thing, we're just going to pair them up. All right? So let's do an example. That's the best way for you to figure out how to use this thing. All right, and I had a nice example in the book. Let me find that one. Where am I? There it is. So let's draw it like this. I'm going to draw it just like it looks in the book. Actually, I'm sorry. Let's try that again. Stretch that out about like that, and go like that. Okay, this is not a right triangle. This actually is bigger than a right angle, and they labeled this as 97 degrees. This angle down here is 21 degrees. They tell you this is 16, and that's all they tell you. They do label it. Let's label it A, B, and C. All right.
If I could please ask the following students to come to the office.
Okay, so here's our triangle right here. Let's label some stuff that we don't know on this triangle. All right. We know angle A. We know angle C. We don't know angle B, do we? This angle B right there. Can we find it like pretty easy? What do you think? What do you think we can do to find angle B? Okay. Right, or in your calculator, just do what? 180 minus 97, what? Minus 21, right? So let's do that. And let's scooch this over about right there. Okay, so 180 minus 97 minus 21. And that gives us 62. So that means this angle B right here is 62 degrees. Well, that was easy. Didn't have to know anything about law of sines or trig or anything else, did you? Pretty easy. But there are a couple other sides on here that you don't know. Let's call this something. Let's label this side AB. Let's not call it side AB. What should we call it according to these letters right here? Little c, right. We'll call this C. And what about this side right here, this AC? What would we call that? Little b. Why? Because it's opposite angle B. Why do we call this C? Because it's opposite angle C. Everybody got that? You understand what I mean by opposite, right? A lot of people get confused. I don't know which one's opposite. Well, look, here's angle B. Straight across from it is the opposite angle. Do you see angle B is made up of those two sides? Well, it's the third side that's not made, that doesn't make up this angle. That's the opposite side. So this would be side B. Now, we're going to use that law sine thing. Let's write it down again. I'm going to write A over sine of A equals B over sine of B equals C over sine of C. Now again, we're only going to use two of these. Which ones are we going to use? Well, let's do this. First of all, let's figure out what we want to solve for first. You have a couple choices. You could either solve for B or solve for C. It doesn't matter. It doesn't make any difference. Which one do you want to solve for? B? Alright, we'll solve for B. In the other class we solved for C, so that's good. We'll do one that's different. Still should be the same answers we got in the other class. So if I solve for B, what we're going to do is we're going to use this one, right? Everybody see that? Because if I'm solving for B, I need to have B in my little formula. Now what we're going to do is we're going to look to see whether we're going to use A or C. So can we use C? Well, I know angle C, don't I? But there's a little bit of a problem. I don't know side C. So I would have two unknowns, wouldn't I? I don't know B and I don't know C. There's no way I could solve using just that equation. So I can't use C because there's a missing part. I have to use a side and an angle that are opposite each other that I know both of them. Do we have that situation here? A, right. I know side A, we'll call this A right here. I know side A and I know angle A, don't I? So that's what I'm going to use. Everybody follow me on that? Because if I'm trying to solve for B, I use the angle that's opposite, right? And then what else do I need? I need these two right here. So there's actually four things that I need. I need to know three of those four things. Do I know three of those four? Yep. I know this angle that's opposite B. I know the angle A and side A. I'm just trying to solve for side B. So let's plug it into this formula. So what we're going to do is we're going to use this right here. All right. We're solving for B. I'm going to put that on top. Over what? B over what? The sine of angle B. What's angle B, though? 62, right? And we had to figure that out on our own, didn't we? That was 62. They didn't tell us that. Now, what should that equal? That should equal a side opposite an angle that we know. Do we know a side and an angle opposite each other? Absolutely, these two right here. So what am I going to put on top then? Well, I know what A is, so I'll put the number in. It's 16, right? Over what? The sine of angle A, or the angle that's opposite 16, and I know that as well. Do you see how I know three of the four things? Look, I know three of the four things right here, and I have to know that to be able to use the law of sines. Everybody see that? I got to know three of the four things. So what am I trying to do? I'm trying to solve for B. So how can I solve for B? You could cross multiply, and that would be completely fine. All right, but I did this for a reason. Since I was solving for B, I put the B on top for a particular reason, just to make my math a little easier, make my algebra a little easier. So if I put B on the top, I could cross multiply, you're absolutely right, but I would have to do two different steps if I cross multiplied. I have to multiply them together, then I'd have to divide by whatever, okay, and sine of 97, and it's just one extra step I didn't have to do. Look at this. If I want to solve for B, all I got to do is get rid of that sine of 62, right? How do I get rid of something that's being divided? I multiply it. That's right. I multiply it by the sine of 62. Now, what's the sine of 62? Well, it's just some number. It's just a number. Watch. Sine of 62. See, it's just some decimal number, isn't it? All right? Don't put that decimal number in here, but I just want you to realize that this is just a regular old number. It's a decimal, but it's a regular number. What about that one? That's also just a regular number, isn't it? So I can do the same exact algebra stuff with these numbers as I could do a regular number, like a 2 or a 3 or a 4 or something like that. All right? So how do I get B by itself? I multiply both sides by the sine of 62. I don't need to show it over here. I know it's going to cancel out, so I'll just mark it out. Now what do I do over here? I have to multiply that by the sine of 62. Everybody seeing that? Just a simple algebra step. This was just a number. It looks a little weird because it's got the sine and the 62 degrees, but it's just a regular number. So if this was just like b divided by 2, how would I get rid of that 2? I'd multiply both sides by 2, wouldn't I? Well, this is kind of like it. It's just a decimal number. So I multiply both sides by the sine of 62. And now I'm ready to write my answer. I just plug that into my calculator. So let's pull the calculator out again. And let's see how to plug it into the calculator. On this calculator, now make sure you know how to use your particular calculator. We've discussed this many times before. Make sure you know how to use your calculator. But I'm just going to use this one because it's the only one I have online. So it's 16 and then sine of 62. I like to close the parentheses. You don't really have to, but I like to. And then what do? Divided by the sine of 97. So I hit divide by and then the sine of 97. And I like to close that parentheses. And then hit equals or enter. And there's my answer, 14.2. I'm looking at the example and it says rounded to the nearest tenth, so we'll make it 14.2. All right. And that's what side B is right there. That's 14.2. It's not so hard, is it? Math was actually pretty easy. right? All I had to do was multiply both sides by sine of 62, stick it in my calculator, bang, I'm done. Setting it up, though, right, was the part that was the new part. You really got to make sure you understand. Let's do one more. We're not finished solving for everything, are we? I've got side B. I've got side A. What am I missing? Side C. So let's solve for side C. So if we're going to solve for C, watch how I set this up. I put the C on the top over what? Look at my formula. The law of sines. What's it say? Over the sine of C. Do I know angle C? I don't. Do I know angle C? Yeah, it's 21 right there. Everybody see that? That scared me a little bit when you said no. You didn't have angle C. It's right there. Angle C is 21 degrees. So it's side C over the sine of angle C equals. Now look, we got to know both of these things now. Now look, we just found B, so I guess you could use B, but that's an approximation. Let's use the original numbers that they gave us in the problem. So what are we going to use again? The 16, right, and the 97. So let's use that. I put 16 on top, and I put the sine of 97 on the bottom. The whole reason that I put the sides on top is just to make this easy for us. So this is already in the numerator. Because if we did it the other way, remember I showed you two ways to do this? If I would have done it like this, where would the side be? In the denominator. And it makes the math just a little bit more difficult for us. All right, I want to make things as easy as I can, don't you? Now, you may not think I'm making it easy, but I am. Okay, after you see how to do these and you get used to this, you'll look back on this and say, yeah, you know, he was showing us something that made it a little bit easier. So how do I get C by itself? Do the same exact math. What do we have to do? That's right, multiply it by the sine of 21. So I get rid of this, and I multiply it by the sine of 21 on both sides. That puts it up top here, and now you just put that into your calculator, and then you get your third side. So let's do that. Again, make sure you're practicing this. 16 sine of 21 divided by the sine of 97. So it's the sine of 97. And then you get 5 point. It says round it to the nearest tenth. Are we going to write 5.7? What are we going to write? 5.8, right, because this 7 rounds this one up to an 8. So it's 5.8. So C is around 5.8. It's not exactly 5.8. It's all approximate. But that's what this is right here. So check it out. We found everything on that triangle then, didn't we? That would have been impossible for you to do before you walked in here today. You would have never been able to find that. You couldn't use trig functions. You couldn't do anything. Now, you could have found that angle. You could have found that before you walked in today. But there's no way you could have found side B and side C, all right, without the law of sines. Well, that's pretty cool, isn't it? Make sure you watch this video. If there's any videos that you watch, okay, it would be this one and the law of cosines, because this is kind of brand new to you. You know the first time I ever saw this? Guess what grade I was in? The first time I ever saw law of sines. 6th grade? How about my first year in college? That's the first time I even heard of the law of sines and law of cosines. Can you imagine that? And here you guys are. What are you guys, like 10th grade mostly? Anybody else in a different grade? All right, everybody's in 10th, yep. So that's a pretty good head start, isn't it? All right, so you can handle this stuff. I promise you can. I never even heard of it when I was in high school. I was never taught this stuff until I was in college. And then I looked at it, and I remember the teacher saying, oh, yeah, you remember this from high school, blah, 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 blah. And she went through it real fast, and my eyes are as big as anything. I'm like, oh, my word, I've never seen that in my life. What is she doing? And I had to go to special help sessions that she gave in the evening and stuff like that to learn how to do this stuff. But now you saw it and you got it online, right? Have your own little special help session at home on the computer, and you can watch it again. Let's do a different problem. We're still going to use the law of sines. Oh, by the way, almost forgot to do this. How can you tell if you can use the law of sines or not? Because not every situation can you use the law of sines. There's basically 3 circumstances where you can use the law of sines. Okay, one is if you have angle, angle, side. So let's take a look at this. What did they give you originally? It's in white, okay? I know there's a lot of junk all around here, but it's in white. What's the original numbers that they gave you as far as your angles and sides? They gave you this angle, and a non-included side, correct? So did they give you angle, angle, side? Yes, they did. So on this triangle, they gave you two angles and a side that's not in between. Well, you could also have angle, side, angle. Two angles and a side that is in between. And here's another one. Give you two sides and an angle, but the angle is not in between the two sides. It's very important right there. If they give you two sides and one angle, you can still use the law of sines. We don't write that the other way, though, do we? That's why I wrote side, side, angle. All right, so the law of sines, this is the situation where you can use the law of sines. Now, in Algebra 2 next year, you're going to be doing this again in Algebra 2. And there's a thing called the... oh my word, it was in my head. Now it just left it. It was called the... oh my goodness. They don't even mention it in this book. So I can't believe I forgot this. I teach this even in Algebra 2. And it just... little brain cramp. It's called... not redundancy. What am I thinking? It's called the... I don't know. I'll think of it when I'm not trying to think of it. You ever go through that? So anyway, here's the law of sines. Here's the three different situations that you're going to use it. So let's draw another triangle. And this time, we're not going to solve for the side, one of the lengths of the sides. We're going to actually solve for an angle. All right, so here's a triangle. About like that. And then about like that. And let's put the stuff in here. This is an example in the book. This is 10. This is 8. It's K, and H up here, and J down here. Alright. Let's see. Does this information right here, is it one of these three? Is it two angles and a side? Do they give you two angles and one side on this triangle? No, they don't. Do they give you an angle, a side, and an angle here? No, they don't. Do they give you two sides and an angle that's not in between the two sides? Absolutely, they do. There's a side, and there's an angle that's not in between. If that angle was in between, if it was in between here, what would this be? This would be what? Side, angle, side, and you couldn't use the law of sines. If they gave you the angle that's in between those two sides right there, you would not be able to use the law of sines. Okay? I'm not going to show you every little situation, but we'll just go from there. Let's label this. Let's label the stuff that we don't know. Well, this is already labeled angle K. This is already labeled angle J. What's the other thing that we don't know? Side KH. We don't know that, do we? But what are we going to call it as far as our letters? We'll call it little j. Is that all right? Why do we call it little j? Because it's opposite angle J. So we'll call it J. Now, you recognize that you don't have to have A, B, and C for your triangle, right? Even though the law of sines says that. You can call it whatever you want as far as the letters are concerned. But we'll call it little j because it's opposite angle J. Now, what are we trying to solve for? We're trying to solve for side J, aren't we? And we are trying to... and we're trying to find some angles as well, aren't we? Let's just find side J right now. All right, this is what we just finished doing. Okay, just like we did before. So how am I going to start this off? Put the J on the top over what? The sine of J. Little problem though. What's the problem? Don't know J, do we? All right, so can I do it that way? Nope. I can't. If I have a side and an angle opposite each other, and I don't know either one of them, I can't solve for them. But I can solve for something else. So forget the J for right now. We'll solve for that in a little bit. Once we find angle J, then we'll solve for side J. But we can't solve for side J right now. So what's another angle you might be able to solve for? How about K? Let's try to solve for angle K. Because we do know a side that's opposite angle K, don't we? And we look at the other two angles with angle H. I know H and little h down here. So that's 3 of the 4 things that I need to know. So let's see if I can do this. I got to solve for this. Remember how I had 2 different ways to write this right here? Which way? Since I'm solving for an angle, which one of these do you think I'm going to use? The red one or the yellow one? Why? Because the angle's on top. You see that? If I'm finding an angle, I'm going to use the yellow one where the angle's on the top. If I'm trying to find a side, which one am I going to use? The red one, because the side is on top. Now, you don't have to do it that way, but I personally think it makes things a little bit easier for us if we do that. All right? Some other teachers would never tell you that. But I think it's a good idea. So look what I'm trying to do. I'm trying to solve for this angle k, so I'm going to put the angle on top. So I'm going to put sine of k over what? If I put the sine of angle k on the top, what am I putting below it? The 10. Why? Because the 10 is opposite. See that? It's not so hard, is it? This law of sines. I can't believe I waited till college to learn this stuff, right? But now you guys are learning it. It's pretty easy once you get the hang of it. What are the two angles? What's this angle inside that I actually know that are opposite each other? This one and this one. So what am I going to put on top? Since the angle's on top here, I got to put the angle on top of the other one. Notice, don't just put the angle there, but what is it? It's the sine of the angle. Okay? Over what? Sine of 45 over 8. Very good. Now, it's nice that I have the k on the top because it makes things a lot easier to solve for. So how am I going to solve for this? Do the same math as we did before. Let's get rid of the 10. How do I get rid of that 10? It's being divided, isn't it? How do I get rid of something that's being divided? I multiply. So I multiply by the 10 here, cancels out, multiply by a 10 over here. What's the best way to show that? The best way is just to stick it right out in front. We're almost done. We're not quite there. Can we just stick that into a calculator and get an answer? No, because that's not going to give me the answer. That's going to give me what the sine of angle k is equal to. What do I want to solve for? Actual angle k. How do we get rid of a sine? We did this when we did the trig stuff. Take the inverse. Good. That's the word I want you to use. Take the inverse of it. So I'm going to take the inverse of all this stuff. I'm going to put all that stuff right in here. So I'm just going to rewrite that again. All right. So that's what I'm putting into my calculator. So let's do that. Again, I'm using this calculator, so make sure you know how to use yours. What I would do on my calculator, I'd hit the inverse sine first, and I'd put all this stuff on here. If you're using a TI 30XA, I would do all the stuff in the parentheses first, and then guess what you would do? Second function sine, and then you should get your answer. All right? So try it. If you have a calculator on you, try yours to make sure you get it right. So on this calculator, I'm going to go second function sine first. It already gives me the parentheses, and so that I can go 10 sine of 45 divided by 8, close the parentheses. Hit equals 62. And it says on these, when you find the angle, it says to round it to the nearest degree, no tenths or anything. So we'll just round it, what, 62. And that's angle K. I'll put that right there, 62 degrees. Now remember what we wanted to do. We wanted to solve for angle J, or side J, didn't we? But our problem was, before solving for side J, we didn't know angle J. But now we can find angle J very, very easily. How can I find angle J now? That's right, 180 minus 45 minus 62. You got it. So let's plug that stuff in. So it's 180 minus, oops, let's try that again. 180 minus, what, 62 and 45, right? 62 minus 45, and that gives you 73. So this angle down here on the bottom is 73 degrees. Now I can use this to find side J. So now it's exactly what we did earlier when we first did law of sines. So now I want to find side J. So which one? What am I going to do? I'm going to put the J on the top, and what am I going to put on the bottom? The sine of angle J, which is 73 degrees. Now I can use that, can't I? Because now I know the angle. Equals, let's use the original information they gave us in the triangle, 45 and 8. So what am I going to put on top this time? Am I? Look over here. Look what I did. I put the side on the top, and then the angle on the bottom, right? So what am I going to put here? 8 over what? The sine of 45. Good. Does that make sense? So they have to both be written the same. If the side's on the top, it's got to be on the top for both of them. Got it? All right, so let's do the math. We did this earlier. Multiply by the sine of 73. So I multiply this by the sine of 73 and plug this into your calculator. Do you have to do an inverse on this one? No. The only time you do inverse is when you're solving for what? The angle, right. Okay, the only time you do the inverse is when you're solving for the angle. This time we're not solving for the angle, we're just solving for the side. So we just plug that in our calculator and see what we get. And that would give us, let's see, 8 sine of 73 divided by the sine of 45. Sine of 45. And that equals about 10.8. It is a side, right? The sides we round to the nearest tenth, so it's just 10.8. So J is 10.8. There it is. And we found everything on that triangle. That's actually more stuff than you're going to have to do on the worksheet. On the worksheet, they just tell you to solve for one thing, right? But what if they told you to solve for side J? You'd still have to find this angle anyway, wouldn't you? So you still would have had to go through this to find 62, to find 73, to find J. All right, so you would have still had to find everything, even on that triangle. What do you think? Does that kind of make sense a little bit? See how that formula works? It's really not that hard of a formula, is it? Just know the formula, know what they represent, know how to plug the stuff in, and then you're good to go. So I'm going to give you a worksheet today. On the worksheet, you only have to do 1 through 8. Okay, you only have to do 1 through 8. The rest of them, 9 through whatever it is law cosines. And we just didn't have enough time to hit law cosines today. We'll hit that tomorrow. All right? Okay, let me give you that worksheet, and then we'll be ready to go.